In our next module, we're going to begin discussing ACI tenant policies, which really is the logical overlay.
So for our agenda, we'll talk about the ACI Logical Model, what is a tenant, we'll talk about a Layer 3 private network, or VRF, we'll talk about a bridge domain, or VXLAN, we'll talk about subnets as a subcomponent of a bridge domain, we'll talk about endpoint groups, or EPGs, we'll talk a lot more about application network profiles, or ANPs, as well as their contracts, subjects, and filters. And then we'll finish up by talking about quality of service, or QoS, in ACI. So to begin with, let's talk about the ACI Logical Model. Now we've gone through a lot of these terms, but we're just going to revisit them very quickly, just in case you happen to watch this module, a few days after having watched your last module. So a tenant, really this is just a logical separator, and really it has to do with authoritative control over the ACI APIC controller. So if someone is accessing directly the web user interface or even via the API, tenants can provide a logical separation of authoritative control. Other than that, there's really not too much physical about them or tangible, other than the fact that with every new tenant, we do have to have a new private network, or VRF. Now there is a way for multiple applications that are modeled as ANPs within multiple different tenants to use the same VRF, and that's by using the common tenant VRF. So we'll talk about that as a subset of design a little bit later. So we talked about the L3 private network. ACI calls this a private network. We also refer to it as a context or a VRF, a VRF. Then we have the idea of a bridge domain. Again, this is not a VLAN, okay? This is maybe what we used to use VLANs for, but remember in VXLAN modeling, we have the ability to reuse VLANs over and over and over. So that is whatever's coming into us southbound from our leaf switches, or actually into our leaf switches from the southbound, I guess I should rather say. All of those, we could have the same VLAN reused over and over and over. But these will come into and be classified as an endpoint group, which we see as the last terminology here. And every EPG has to be classified into a bridge domain, which is our VXLAN VNI, or VXLAN network identifier. Within bridge domains, we have either one or multiple subnets. Now, the subnets do have to be unique within their private network, or VRF, just like subnets have to be unique in a, let's say, multiple SVIs, can't have overlapping IP addresses in a traditional switch, provided that they are in the same VRF. If they're in different VRFs, then of course all of a sudden we would support the reuse of IP addressing space. Now, we do have the ability to do route leaking between VRFs within a tenant, as well as between tenants. And we'll take a look at that as a special use case. Not really that special. I actually see it happen quite a lot. But we'll take a look at that as a design use case a little bit later in a future module. But just kind of know up front that we do have the ability to do VRF route leaking within a tenant or even between tenants. It does take more work to do between tenants because really both sides have to comply and utilize that route leak, because remember that tenants are a logical separation of authoritative control. So we wouldn't just want to allow one tenant to export routes into another tenant without the other tenant accepting that. So that has to be accepted by the other side, and then the other side has to export their routes, and then they have to be accepted by the first side. So we'll take a look more at that later. And then contracts. Remember, contracts they allow communication between EPGs. So we'll take a lot more of a look at this, but keep in mind that ACI is a whitelist model. So basically, unless you're on the list that allows communication, unless there is a contract, there is no communication between EPGs by default. You must have a contract. So taking a look at the logical model overview. So here we see that at the top we have the root or universe, uni. And then we have multiple tenants, tenant A and tenant B. Now tenant A has two VRFs, VRF A and B, and tenant B has one VRF A. Now if these, and just private L3 is just what ACI calls them. So let's just say that tenant A is named A and the VRF or private network is named A. Now tenant B also has a VRF named A. So how will this get instantiated into a leaf switch? Well, actually, whenever VRFs are named in a leaf switch or instantiated by the fabric, what we'll see is that they're a concatenation of the tenant name and the VRF name, or the private network name. So the actual VRF is not just the private network, it's the tenant name and then colon and then the private network name. So that's what actually equals the VRF. So if I have this private network here of A within tenant A, I would see the VRF, if I did a show VRF in an XOS mode, I would see VRF A colon A and A colon B, which means that it's different from B colon A. So that would be a separate VRF. Assuming that we had EPGs on all of these, we would have essentially three VRFs, A colon B, and B colon A, all on the same leaves. Okay. So any bridge domain must be linked to, associated to, or a part of a private network or VRF. So here we see a bridge domain. We don't really have a name for it per se, but it's in VRF A. And we have subnet A. Now we also have VRF B with a bridge domain, and it has subnet B and C. And technically these could be overlapping with A, so I could have A here. Maybe this is 10.1.1.0. And this subnet over here could be 10.1.1.0 because they're in two separate VRFs. Now, if I wanted to do route leaking between them, they would have to be unique. Likewise, over here in tenant B, VRF A, in its bridge domain, it has subnet A. So maybe this also is overlap or reused IP addressing space 10.1.1.0. So we could not do VRF route leaking between tenants for subnet A and A without some sort of NAT being involved. Now, NAT is currently not an inherent feature that's supported inside the fabric, but you could always route it outside the fabric, perform the NAT, and then bring it back in. Of course, we wouldn't really do route leaking at that point. We would be doing something we'll talk about a lot more later, which is OSPF, EIGRP, or I or eBGP routing out, or even static routes outside the fabric, do our translation, and then route it back in. So these would be two separate L3 outs. But we'll talk a lot more about that later. So notice that bridge domain here in tenant A, VRF B, does have two subnets. And this is perfectly legal. You can have as many subnets as you want. And for every bridge domain, which is a VXLAN VNI, for every subnet within every bridge domain, an SVI is created. Now actually I should back up a little. Not for every subnet within a bridge domain. So here in this bridge domain, we do not have one SVI for subnet B and a second SVI for subnet C. Rather, we have one SVI, and the idea is that we have one of those subnets would be the preferred subnet, so it would be the primary, and the others would not be flagged as preferred or primary, so they would simply be IP address, let's say 10.3.3.0/24 secondary. And this is really what's happening. Even though there's no show run, if we did other show commands, we might be able to see that that's actually how that is flagged. It is a secondary IP address. Now note in any bridge domain, we could have a single EPG mapped to a bridge domain, or we can have multiple EPGs mapped to a bridge domain. And really, the limiting factor that would, and I'll kind of just state this right up front, that would determine whether you could have multiple EPGs attached to the same layer 2 VXLAN bridge domain or not would be, do I need to perform any sort of layer 4 through layer 7 services between them that specifically those L4 through L7 services are controlled by ACI. So ACI can work with any L4 through 7 service, any firewall, IPS, IDS, load balancer, but there are certain firewalls, load balancers, IDS, IPS, and more coming on board every day that have what are called device packages, and we'll talk a lot more about those in detail in a module of their own. And those can be controlled by ACI. So the ones that need to be controlled by ACI would actually have to have a separate bridge domain per EPG if we wanted to instantiate or invoke services between those EPGs. If all they need is communication, a simple contract, either stateless or stateful firewall, instantiated directly in the fabric, in the leaf switches, then it doesn't matter. We could certainly have multiple EPGs in the same bridge domain. And there would be no communication between them unless we allowed the traffic via specific ports in our contract. Okay? So just because they're in the same layer 2 VXLAN does not mean there's any communication between them. And we'll be talking a lot more about that as we go into bridge domains and some of the differences between the older releases, which you may be used to working with, or maybe which you have in your lab, so 1.02, 1.03, 1.04, and the newest release that I keep mentioning, 1.1, which is Brahmaputra as the code name, that just was released a few days ago as of this recording in June 2015. So there is some very specific new security models and things that we can do to prevent all communication between EPGs, whereas before it was mainly unicast that was prevented and broadcast and multicast was allowed. So we'll talk a lot more about that. So we've already looked at this management information model. It's just here for your reference. I'm not going to go over all the one-to-N, N-to-1, and N-to-N relationships again, but do take a look at it and use it for reference. So let's now talk about a tenant. We've already mentioned that a tenant is a logical container for application policies. And there are 3 pre-configured tenants. I'll start in the middle with the infrastructure. Okay? This creates a VRF in all leaf and spine switches named overlay-1. And this is the VXLAN overlay infrastructure that manages all of the communication between APIC and the nodes, the leaf and spine switches. So all communication is over this particular infrastructure overlay VRF. Then we have the management. So management is not used for APIC management of the leaves. That's the infrastructure or infra. However, the management is used for the management by us as human administrators. So whether we want to do this in-band, if our devices that are managing the fabric are attached in-band to a leaf switch, maybe to a 10 gig port, or out-of-band if the devices we're using to manage are attached through the 1 gig management 00 of each leaf and spine switch as well as the APICs. And then there is the common tenant. Now the common tenant contains policies, endpoints, endpoint groups, services that really can be accessed by all other tenants. So most tenants we're going to talk about, if they want to have inter-tenant or tenant-to-tenant communication, they must have an explicit exported contract, and essentially this will set up, of course there's a few additional steps, that it will set up VRF route leaking between tenants. However, there is the common tenant, and we do have the ability to have pretty much every tenant, without doing any exports, can access anything in the common tenant. So this is visible by all tenants, so it really is a very special, unique kind of exception of a tenant. So this is where we would put things like, Active Directory or DNS or just our open LDAP or NTP, anything that we want everyone to have access to. And there's actually some interesting design scenarios. In fact, I've used this quite a lot in designs that I've architected, whereby all tenants do not create layer 3 private networks or VRFs or layer 2 bridge domains for VXLAN in their specific tenant, but they create them in the common tenant. And we'll actually see why you might want to do this as we take a look at some design use cases in a later module. So from here we see that we have the ability to add a tenant, and once we create or add a tenant, we give it a name. We then can create, and I highly recommend that at the time you create a tenant, you go ahead and create a security domain of the same name. Now, all tenants will always be a part of the all security domain, but I highly recommend that you create a security domain that's the same name as the tenant. And essentially what this would be used for is RBAC, role-based access control later, to say a particular user, whether admin or lower level privilege that can only read and write to some things, maybe even only read, has access to this particular tenant or does not have access to this particular tenant. So let's now talk about a layer 3 private network, also called a context or a VRF. So this private network represents the application policy domain and the layer 3 forwarding. Now, we can have more than one private networks or VRFs associated with any tenant. We also can have more than one bridge domain or just a single bridge domain associated with any private network or VRF. So we can have multiple VXLANs inside of a VRF, okay? But again, IP addresses within the VRF do need to be unique. So we can see the management information model here, where we have uni, and then tenant, and then our VRF. Now, what we're actually showing you here is the naming convention. So this would be, for instance, in a RESTful API, we would have at the top level, the root level, we'd have uni. Then we'd have tn dash, and then the name that you called the tenant, and then ctx dash and the name that you called the VRF. From a representation in terms of your JSON or your XML, you'd have pol uni, so policy for the universe, FV, which is functional virtualization or functional value, can never remember which, for a tenant, and then your functional value for your context, also called your private network, also called your VRF. So yes, unfortunately, we have 3 names for a VRF, private network, context, or VRF. Just keep in mind that whenever you were on a traditional Nexus switch, you always said, you always created your context for your VRF. So VRF, context, and then your name. So those two should really be synonymous. Now we're adding one more name, private network. So we see that some of the settings and the policies that we have on here is we can choose whether policy is enforced or unenforced for a particular VRF. Now this means if it's set to, and by the way, it's set to enforced by default, but if we changed it and tagged it as unenforced, then any VXLAN bridge domains that we created as a subset of this, and any EPGs that use those bridge domains, so therefore we're a subset of the bridge domain and then natively as a, or implicitly as a subset of the VRF, they would not require any contracts between them to have any communication. Okay, again, assuming that all the EPGs were within this particular private network or VRF, there would not be any contracts needed. Now, that's not recommended, but it is possible to go ahead and switch it to that model. So we also see that we have unique BGP timers, OSPF timers, we now have EIGRP timers, and keep in mind most of my screenshots are not updated for the new release, so I'll call out anything new, and then when we go into demonstration, you'll actually see some of those new fields. So now let's talk about a layer 2 VXLAN bridge domain. So again, we really want to drive this home. This is not a VLAN. So each private network can have one or more bridge domains, but each bridge domain must be linked to a private network. Now keep in mind that ACI is a declarative model, meaning it doesn't necessarily force you on the web user interface to configure everything that you may need to configure. You will get a fault raised. So for instance, if I created a bridge domain and I did not link it to a network or private network or VRF or contexts, all the same thing, By the way, it sometimes is just called a network rather than private network. So we'll actually see this on the next screen here. Okay, so it just says network rather than private network or VRF or context, but that's what this is. If we didn't set it to that, we would still be able to save the page, but we would hopefully see, and it's always a good idea to check, to see if we have any faults raised. Okay, so you do have to associate a bridge domain to a VRF for it to be instantiated on any leaf switch. Now, each bridge domain should have at least one subnet if you're doing IP routing. If you're not doing IP routing, which we'll talk about, then it's not critical that you have a subnet. Okay, a bridge domain can span across switch nodes, so do keep in mind that we have the ability to have, as soon as we create a subnet within a bridge domain, this instantiates an SVI, and because we're using Anycast, the same IP address and the same MAC address for the SVI will be instantiated on every leaf where an endpoint is detected matching this bridge domain. And as we get into more detail, you'll understand how an endpoint matches a bridge domain, or how it gets mapped to, and then when the fabric sees it, how it goes ahead and instantiates that SVI on the leaf. And we'll take a look at a lot of detailed examples where we move all endpoints out of an endpoint group, out of any bridge domains completely off of the fabric, or I shouldn't say off the fabric, off of one leaf, and how the SVI just gets destroyed, right? So all of our resources are freed up. Now, it is important that MAC addresses are unique within any bridge domain. This would just be like in a traditional network, how MAC addresses would have to be unique within a VLAN, right? Now, in our new networks, we're going to have multiple customers in a colo data center or in a cloud, private cloud environment, or even possibly public cloud, depending on how we have that modeled and depending on what we want to call it. But at any rate, if we have multiple MAC addresses, let's say we have 2 tenants and we have, or let's say we could even just have one tenant, and that one tenant has a development environment and a production environment. Maybe they also have a test QA, but we'll just keep it simple at 2. And they have a UCSB series with a MAC address pool in their development environment and another one in their production environment. And they've assigned the same MAC address pools, either not thinking or not caring or intentionally, to both the exact same MAC address pools to both their dev and their prod environments. As long as they're a part of 2 separate VXLAN bridge domains, this isn't a problem. If they were all in the same bridge domain, this obviously would not work. So whether that was a traditional VLAN in the old model or now, this is a VXLAN. Okay, so bridge domain used to equal VLAN in a legacy model. In a ACI or anything to do with VXLAN, our bridge domain is our VXLAN. Now, if also one other thing, if we wanted to have route leaking between VRFs or even communication between bridge domains, those, at that time, any of that combination would also have to be unique VLAN. Sorry, I just got done saying it's not a VLAN, right? Would have to be unique MAC addresses between the VXLAN bridge domains. So here's a picture, a screenshot of our bridge domain. And we can see that this is actually just the create step screenshot where we're giving it a name, VM data. By the way, we do not assign the VXLAN VNI. So like in a traditional legacy environment, we would assign a VLAN ID, and then we optionally could assign a VLAN name. Here in our modern VXLAN bridge domain environment, we do not assign the VNI. That's automatically assigned by the fabric, and it is kept unique inside the entire ACI fabric, of course. We do have to assign a name. Pretty much everything in ACI has to have a name, and that becomes its managed object canonical name, and ultimately goes into its DN or distinguished name. We have to assign a network. We have to talk about how the forwarding is used, and we'll talk a lot more about that. We may configure manually the MAC address or just allow it to use its own MAC address. We can put on an IGMP snooping policy. We'll talk a lot more about layer 3 out, which has to do with external routing outside the fabric for or mapped to this particular VXLAN bridge domain. So we'll talk a lot more about that. And then if we were assigning a route profile, what is the L3 out for that route profile? Any DHCP relay, any monitoring, and endpoint retention timers. So we'll talk a lot more about that as we go on. So layer 2 forwarding behavior in the bridge domain. So the ACI fabric is what is called host routed. So what this means is that the ACI fabric is not only learning MAC addresses like a legacy environment would, but it's also learning all the IP addresses. And this is what allows us, and we're actually going to take a look in a lot more depth in the next module with ACI operations and fabric forwarding. But this is what allows us to eschew the need for L2 unknown unicast flooding and ARP flooding. Okay, so we actually have the ability to peer in, or the fabric has the ability to peer into an ARP request, look at the payload, and say what is the destination IP address that you're seeking the destination MAC as a match for. And while the ACI fabric does not reply on behalf of the other side, it knows the IP address that you're going to, or at least we hope it does. And if we do, if we've learned that IP, then we'll go ahead as a leaf switch and we'll unicast that packet over to the VTEP, or the VXLAN tunnel endpoint of the other leaf that owns that IP address for that host. And then from there, it will be continued on. The ARP packet doesn't really get modified. It will go on to the host and the host will reply. So this is from a brief overview, and we'll go into more detail, what allows us to go ahead and get rid of L2 unknown unicast as well as ARP flooding. Now, what if the destination, what if there was no layer 3 header, or what if we didn't know the IP address of the other side because we did not have unicast routing turned on? And in order to learn IP addresses, this tick box down here, or checkbox if you want to call it that, for unicast routing does have to be enabled. So this unicast routing is what A, creates the SVI if we have a subnet, and B, allows for unicast routing. If we don't have this enabled, neither will happen. And if we flag this on or off, or we flag on or off ARP flooding or L2 unknown unicast flooding or hardware proxy, anytime we make changes to those, the fabric will actually flush all MAC and IP addresses from any endpoint groups that are using this bridge domain. So it is important that you, and I think you get a warning before you say OK to that. But it is kind of something to take note of. We'll take a lot more look at multicast in a little bit as to flooding or optimized flood. Okay? So what happens if the destination MAC was known? There would be a lookup for the location to route to the egress leaf. Okay? So we would still be able to route or switch based on MAC address only, even if we don't have the IP address knowledge of the other side, or if there was no L3 header, if it was an L2 only frame. You can see also, before we move on, that there is something called a segment ID, or just a segment, and this is actually the VXLAN VNI. Okay? So this is the VXLAN virtual or VXLAN network identifier. Okay? This would be equivalent, if you were back in VLAN days, to your VLAN ID, but now it's your VXLAN ID. And remember, it's a 24-bit number, so it's a rather large number. Again, it's automatically chosen for you. There is also a network, or our private network, and we can see whether it's coming from our tenant or whether we're actually borrowing and using a private network from the common tenant. There's a custom MAC address. There's actually a new field here for what to do with broadcast. So by default, or I guess I should say in the older ACI 1.0, the Amazon release, we could not block broadcasts or multicasts that were transmitted between EPGs within the same bridge domain, or VXLAN. Now, with the Brahmaputra, or ACI 1.1, that was released just in June 2015, we have another field in between these two. And this is what to do on broadcasts. So do we go ahead and flood them? Do we, really it's all bum traffic, right? Broadcast, unknown unicast, and multicast. Do we drop them, or do we go ahead and just flood them within the same VXLAN? Okay, so this is important, or actually, sorry, within the same VLAN identifier for any given EPG. So this is actually a new functionality. It is still set to the default of ACI 1.0. Typically, once a value is set in most Cisco products, they don't change the default value, even if you might want it changed. That way, when you perform an upgrade, you're not met with unexpected results because things have changed, right? There's new features or new nerd knobs, as we like to call them, but they're not necessarily flipped to on. So the impetus is on you to go ahead and flip those flags to on. So we can flip that flag to drop now bum traffic between EPGs within the same bridge domain.